Here's a warm-up example, getting used to working in polar coordinates. So I've drawn a little polar grid here by hand. So hopefully this is good enough. You're comfortable working with this. Okay, and then the example is to plot these points that are given in polar coordinates and then give two other sets of polar coordinates that correspond to that same position in the polar plane here. So a few things, since this is the first example video using polar coordinates. In these pairs here in polar coordinates, the first value is the value of r. That's the distance from the origin. And then the second entry here is an angle theta, which is measured from the positive x-axis, which we call the polar axis, this axis here. So we always start here and then rotate theta degrees, keeping in mind that positive direction is counterclockwise. Okay, so first we want to plot the point 2, 3 pi over 4. So I'm going to label a few angles here. So the positive x-axis, the polar axis here, corresponds to 0 radians. And then up here we've got pi over 2 radians. So halfway between those, so this ray right here corresponds to pi over 4 radians. We want 3 pi over 4. Okay, so let me keep going around. So rotating all the way back to the negative x-axis would be pi radians. And then halfway between these two would be 3 pi over 4. Let me go ahead and label the other fourths working around the circle here. So this would be 3 pi over 2 down here, and then 2 pi when we're back in this position. So dividing quadrant 3 exactly in half, we'd have 5 pi over 4 radians here, and 7 pi over 4 here. Okay. So if we want to plot the point 2, 3 pi over 4, then I would first find the ray that corresponds to 3 pi over 4 radians. So that's this ray right here. Let me highlight that. So we're focused on this ray here, and we want to go out 2 units from the origin. So that's what these circles in a setup in polar graph paper or in a polar grid here. The circles represent the collection of points that are 1 unit out from the origin, and then 2 units out, 3 units out. So we want the point along this ray here that is 2 units out, so that's going to be the second circle out. The circles indicate, each unit of distance from the origin. So 2, 3 pi over 4 corresponds to this position right here. Now we want to come up with 2 other sets of polar coordinates corresponding to that point. So there are a couple of things we could do. One might be to use a negative value for theta. So let's say so the 3 pi over 4 radians was when we rotated around this way. Let's say we rotated in the negative direction around this way. Then that would be, let's see, so from the positive x-axis here, rotating all the way around this way would be negative pi radians, and then another fourth, so that would be negative 5 pi over 4 radians to rotate around to this ray in the negative direction. Because again, it's when I rotate, here's negative pi over 2, here's negative pi, and then another fourth, negative 5 pi over 4. So one other set of polar coordinates, we're still going out positive 2 units along that ray, but negative 5 pi over 4 for theta. Or you could use a negative value for r. So the way we could do that, let me get another color, is suppose we used not this blue ray that I've highlighted here, but this ray. So 7 pi over 4. Use this ray, but use a negative value for r. So if r is negative, then you go in the opposite direction. So if we have 7 pi over 4 as our theta, but use a negative value of r, that will move us back into quadrant 2. If we use negative 2 for r. So there's another set of polar coordinates. Or something else you could do, you could just add 2 pi to whatever your value of theta is. So I could have just taken the 3 pi over 4 that's here and just added 2 pi, which would be 8 pi over 4. So I know I only asked for 2, but another set of coordinates would be 2, 11 pi over 4. That would also correspond to this position here. 11 pi over 4 radians would be if we go all the way around the unit circle, so that's 2 pi, which is 8 pi over 4, and then another 3 pi over 4. We'd land here. Okay, so that's the 2, 3 pi over 4. So as another example, and this is where I'm going to have a little bit of trouble. I'm going to try to get rid of most of my writing here. But as another example, we wanted to do negative 1 pi over 2. So let's see. Get rid of most of this. Negative 1 pi over 2. So pi over 2 radians, so that corresponds to this ray right here. Negative 1, so again, that means you go in the opposite direction. So if this is the negative pi over 2 radian right here, we go in the opposite direction, that's going to move you to this position right here, along the negative y-axis. So there is that point. This is the point for B. If we want to give other polar coordinates corresponding to that point, well, it is usually best if you use a positive value for r. So what if we had a positive 1 for r and then 3 pi over 2 for theta? I think that would be the most obvious choice as another set of polar coordinates corresponding to this point. Or you could use a negative theta like I did before. So say you revolve around this way and call this ray right here negative pi over 2. And then again use a positive value of r since we're moving out along the same direction corresponding to that ray. So negative pi over 2, positive 1. There'd be another set of polar coordinates corresponding to that point. Okay, and then one other example I wanted to do in this video. So example C here. Okay, let's say the coordinates are 3, negative 2 pi over 3. One last example. Okay, so first we need to identify the ray that corresponds to negative 2 pi over 3. So I'm going to label the thirds here. So this would be pi over 3. This is pi over 6. Here's 2 pi over 3. 3 pi over 3 would be a whole pi. 4 pi over 3 will be right here. This is 7 pi over 6. Where are we? 5 pi over 3 would be right here. And then 2 pi is 6 pi over 3. Okay, so negative 2 pi over 3 radians. So if we go negative 2/3, then that's going to land you, that's this ray right here. Is negative 2/3, negative 2 pi over 3 radians. So it's kind of the mirror image of your 2 pi over 3 ray up here. So this 4 pi over 3 ray also corresponds to negative 2 pi over 3. And then if we move positive 3 units out along that ray, so 1, 2, 3 circles out, this would be the point corresponding to that point C. If we want another set of polar coordinates, well then the obvious choice here would be to just use 4 pi over 3 and positive 3 for r. So that would work. Notice that another way of getting from here to here is to add 2 pi, which is 6 pi over 3. Would give us 4 pi over 3 right there. You can always just add 2 pi to your theta to form a to get another set of polar coordinates. Or, okay, let's say we use a negative 3 for our r. Our r. Okay, then that would be negative 3 units. So we want to go in the opposite direction of this ray here. So of the pi over 3 ray, but go negative 3 units, that'll move you back into quadrant 3 here. So there's another set of polar coordinates corresponding to that point at 3, negative 2 pi over 3.